so I have this question here. Yabapana June 2026, paper 3 is ZIMSEC Ekₘₐₓ. ZIMSEC. Right. So this question is about photoelectric effect. I'm just going to give a very small explanation of the photoelectric effect to those vasinganya zvavo kuita se or vasati vaita kuchikoro. The photoelectric effect basically experiment inobudisa the particle nature of light. Currently the particle nature of light, what am I trying to say? Light vamwe vanoriziva as a wave, but from the understanding yatinayo kubva kuquantum physics, we understand that light is a particle. So as a physics learner, when you are looking at light, and it tomboti iri light, right, we are towards a what? This one is a metal plate. This one is a metal plate. So tomboti iri light we are towards a metal plate. As a physics learner, when you are looking at this light, you wafanongoroona se light nje. Light iri tichiri understanda takavhura maziso edu ephysics, tinoroona as if it is made up of some particles, and these particles we call them photons, right? But what is a photon actually? A photon, a photon, when we are defining it, it is just a packet of energy, and it of light or of any EM radiation. So my photons are an energy. Energy my photons are to calculate, say we use E is equal to HF. This is the formula that we use to calculate energy of the photons. E into energy, H is called the Planck's constant, and F is the frequency. We use this formula to calculate what? To calculate the energy. So chimetal plate chindachiisire yapa ichi pakaitwa experiment ranaputaura re photoelectric effect. Photoelectric effect. When this experiment was done, pakaonekwa kuti ma photons are the moment yanondosvika pametal panapa panobva pa ejectwa ma electrons. These are now electrons which are being ejected from the metal, and it ndo zvakaonekwa nemascientists, right? Ma electrons awa nenyaya yekuti azo emitwa or azo ejectwa after pauya ma photons first, tinobva tamapa isusu a special name, atingomati ma electrons chete, we call them photoelectrons. We call them photoelectrons, right? But from an understanding of energy, right, so from an energy perspective, tifana ku understand kuti my electrons are kuti agotanga kubuda and it haangobudi mumetal. Number one, anoda sufficient energy, and it, so I'm saying for electrons, right, to be emitted, what am I saying? Enough energy, right? Enough energy is required. So a minimum amount of energy inodiwa kuti my electrons awago emit. That minimum amount of energy inodiwa ndo inonzi work function. Saka work function inodependa nemetal. Kana iri metal yedu iri ion ine minimum energy inoda kuti my electrons awago emit. Kana iri sodium has its own minimum energy or has its own function, that its own work function that is required for its electrons to be ejected. So work function is a property of a metal, and it, but basically the work function, this is the minimum keyword energy required for photoelectrons to be emitted from a metal surface. From a metal surface. From a metal surface. Sometimes we'll say from a cold metal surface. But that one, emphasize emission haisi thermal ionic emission. Here inodependent here, but it's photoelectric emission. Right. So I was discussing about ideal energy. So let us say, let us just use a simple numerical example. Let me say this one is a metal, not a photon. Then photon is a metal pedal. Maybe energy right now it's 15 joules. It's just an example, and it's right. Then could my electrons are go emit. For example, let us say this metal is magnesium. Could my electrons are go emit kubva pasurface ye magnesium. Tomboti magnesium inongoda iyo 5 joules. Right, e 5 joules ndo inenge iriyo work function. So kana photon rekati provide energy 15 joules. Let me just say this energy is E. Then this work function is represented by a symbol phi, sin phi. Saka 15 joules zasvika pametal surface, then electron 1 emitwe, my electrons are emitted, the work function, the minimum energy required is 5 joules. So pasarama joules mangani from 15, pasara 10 joules. 10 joules zasara idzodzo ndo dzinoshandiswa nema-electrons paanenge achimova, meaning that it is now in form of kinetic energy maximum, Ek max. So basically I'm simply saying 15, which is the energy of a photon, right, is equal to 5 joules, which is actually the work function, plus 10 joules zazosara idzi, which is actually the maximum kinetic energy, Ek max. So this equation, we must know this equation by heart. Same as the Roman get our lyrics. Right. So let us try to answer the questions. Question number 1. Calculate the energy of a single photon. Energy of a photon, we have said, is given by E is equal to HF. And let us substitute. H is the Planck's constant, which is 6.63 times 10 to the power negative 34. The Planck's constant, the paper data sheet. Then F is the frequency, which is 1.15 times 10 to the power of 15. So what is the energy of a single photon? Let's calculate, guys. Let's press our calculators. So from my calculation here, I am getting 7.62 times 10 to the power of negative 19 joules. No energy here, one photon here. Rondosvika pa surface. Calculate the maximum energy of the electrons. So as you can see, we are going to use our equation. This equation andanyora ukapononzi 2 instance photoelectric equation, or pakamonzi 2 photoelectric equation. Ndoireri photoelectric equation. Here it is. So this is the equation that we are going to use. We are going to substitute the value of E here. E is equal to 5 plus Ek max. And here we are looking for Ek max, so we are going to take phi to this side, which means it is going to be E minus phi is equals to Ek max, maximum kinetic energy. And if we plug in the values, the value of E, Taiwan upon up, 7.62 times 10 to the power minus 19 minus phi. Phi is called the work function. Phi is called the work function. So if you go back to our question, the value of the work function is there. This is the work function of the metal, 2.8 times 10 to the power minus 19. 2.80 times 10 to the power minus 19. This is going to be the value of Ek max, the maximum kinetic energy. And what is the answer? if I say that one minus 2.80 times 10 to the power of minus 5, minus 19, sorry, minus 19, the answer is 4.82 times 10 to the power minus 19 joules. So this is the maximum kinetic energy yema-electrons. Kura ma-electrons edu awa paanobva apa pa-metal surface after aejectiwa anenge achifamba, and the kinetic energy anenge achifamba nawo, here it is. Now we are supposed to calculate, so this one was number 1, this one is now number 2. Now we are supposed to calculate number 3, the maximum speed of the emitted photoelectrons. The maximum speed of the emitted photoelectron. Ma-electrons edu pano emitwa anenge aine speed yakakura sei. So this question yafano kunetsa, unofana kugona kungorealize chinhu 1 kuti speed handiti tunoiwana papi, tunoiwana pana half mv squared. Half mv squared yakamirira chizviya, yakamirira kinetic energy. Tutose reve mwana wechikoro. Very good. So usatambura nequestion yakaita se we are going to say half mv squared, but its maximum here, don't forget that, is equal to Ek max. Is equal to Ek max. So let us put the numbers. Half m mass electron. Mass electron is 9.11 times 10 to the power negative 31 multiplied by v squared is equal to Ek max. Ek max taiweka pano up 4.82 times 10 to the power of minus 19. Okay, minus 19. So we are going to make v subject of the formula. So v is going to be equal to the square root of 2 by 4.82 times 10 to the power minus 19 all over mass electron 9.11 times 10 to the power negative 31. Then this is going to be the value of v, the maximum speed of our photoelectrons. Let us calculate. Kana ndisina kuresha kubaya calculator yangu ndawana 1.03 times 10 to the power 6 meters per second. So this is the question, guys. This is the question. So it's all about you knowing the basics. Question you're asking about Goshi.